Hi, today we will be learning about quadratic graphs in standard form. A high school baseball player throws a ball straight up into the air for his math class. The math class was able to determine that the relationship between the height of the ball and the time since it was thrown could be modeled by the function h of t is equal to negative 16t squared plus 96t plus 6, where t represents the time in seconds since the ball was thrown and h represents the height in feet of the ball above the ground. The ball's path is graphed to the right. As you see, there are key points on here. There is your x-intercept, there is your y-intercept, and there is also another x-intercept. And the other point at the top is the vertex, which we will talk about a little bit later on. Use the graph and the situation above to answer the following questions. What does the domain in the context of this function represent? Well, remember, our domain is our x. Since we do not have x's in this one, we have to look where x would be in the function. X is t. So what does it tell us that t represents? T represents, it represents the time in seconds since the ball was thrown. All right, and remember, range is represented by y, in this case is h, and that is the height in feet of the ball above the ground. It asked, at what height does the ball get thrown? Well, if we think about that, that is our y-intercept, which is 0.6, so that would be 6 feet. After how many seconds does the ball hit the ground? Well, that's going to be our x-intercept way over here at the end, this one, because this line right here represents the ground. So that would be 6.062 seconds. Question 5 says, what is the maximum height the ball reaches while in the air? Well, that goes back to our special point called the vertex. And our vertex was at the point 3, 150. So if we think about that, this is x, this is y. Go back over here and look at 1 and 2. We're talking about height, and that was this right here. So that would be our y value. So our height would be 150 feet. And it says, how long does it take it to reach its maximum height? Well, that is our time, which is our x value. So that would be 3 seconds. And it says, what feature of this quadratic function is visible since it is graphed in standard form? Well, when you graph it in standard form, if we come back up here and look, we will notice we get the number 6. And if we look, 0.6 is right there. That is our y-intercept. So the y-intercept, which is 6. All right, if you will turn to the next page, please. Now we have the same graph. So this is the graph that we were just given. And we're asked to find some stuff out about this function. It says the function h of t is negative 16t squared minus 96t plus 6 is graphed to the left. Identify the following characteristics using interval notation when necessary. All right, so the x-intercepts. Remember, these are points. They are going to be a number, comma, 0. So if we look at our graph, we have negative 0.062, 0, and we have 6.062, 0. Same with the y-intercept. It is also a point, but this one is going to be 0 and a number. So if we look over there on our graph, that is going to be 0, 6. Your roots, your solutions, and zeros, they are just x values. So they are the x values of the x-intercepts, which is negative 0.062 and 6.062. This is also the place where they cross the x-axis. I should have done that in green because it is the ground. It's where they cross the x-axis, which is the ground. All right, our vertex is that point way up top. It's going to be the highest point on this particular graph. It is a point. In this case, it is 350. Now we're going to talk about something called the axis of symmetry. The axis of symmetry is a line which you can fold the graph in half. It is always going to be written as the equation y equals x equals a number, sorry. And to find that number, I'm going to make a little asterisk. You're going to use the formula x equals negative b over 2a. Now you may ask me where these numbers come from. In a function, a quadratic function, they are written ax squared plus bx plus c. We are looking for a and b to be used in this equation. So if we do that with this equation, we have x equals negative 96 over 2 times negative 16. We put that in our calculator, and we get x equals 3. The way you show that on your graph is you make a dashed line, except I'm not making a dashed line. I'm just drawing a straight line with a highlighter, and that will be the axis of symmetry. Now your domain, remember that is x values. What values can we plug in for x? Realistically, we're only talking about what we can see. So it is going from 0, sorry. Yes, it is going from 0, because that's where it starts, to 6.062. And they both give brackets because that's where it starts and it stops. All right. The range is based on the y values. Our smallest y value is 0, and it goes all the way up to 150, which is the vertex. Now, our interval of increase and interval of decrease is based off of our domain. Okay? The other way I like to talk about this is, are we going up the roller coaster hill or are we going down the roller coaster hill? Interval of increase would be going up the roller coaster hill. So we are doing that from 0 to 3. And then at 3, we start going down the roller coaster hill till we get to 6.062. Now 3 gets a parenthesis, even though it's a point, because technically at 3, it's doing two things. It's increasing and decreasing. That is called a turning point, which we will talk about later on. The absolute max or the absolute min. This is going to be the y value of your vertex. It will either be one or the other, not both. So do we have a high point on the graph or a low point on the graph? We have a high point, so our absolute maximum is 150. We do not have one for an absolute minimum. In behavior is where's the graph going? As it approaches negative infinity, it is going to the value of 6. And as it approaches positive infinity, it is going to the value of 0. All right, we're going to come over here and talk about average rate of change, or AROC. On the interval a comma b, the average rate of change is f of b minus f of a over b minus a. Basically what it's saying is you're taking the first point, or the second point minus the first point. The y is on top, x is on bottom. You could also think of this as your slope formula. So y2 minus y1 over x2 minus x1. We are using 0 and 3. So 0 is 6, and 3 is 150. So we have 150 minus 6 over 3 minus 0. So we have 144 over 3. And we plug that in the calculator. 144 divided by 3 is 48. And that is our average rate of change. All right, example number 1. It says graph the quadratic function. First, it wants us to find the y-intercept. Remember, your y-intercept is always by itself. So our y-intercept is 0, 7. And we'll go over here and we'll graph it. 0, 7. Okay. Next, we find the axis of symmetry. Remember, that is x equals negative b over 2a. And I put that in the calculator. And I get x equals 2. So I come over here. X equals 2. And draw me a line. Okay. Now to find the vertex. To find the vertex, I know it's got to be on that axis of symmetry. The vertex is on the axis of symmetry. Okay, so I plug it in. So f of 2 equals 2 times 2 squared minus 8 times 2 plus 7. Or f of 2 is equal to negative 1. So my vertex is 2, negative 1. So I plot that point. Now it says reflect the y-axis, the y-intercept across the axis of symmetry. If I look, it is 1, 2 spaces. So I come over here and I go 1, 2 spaces. And I put another point there. So they will match up. So that point I graphed was the point 7. The next thing says plug in more x values for points if needed to get 5 points. Well, we have 3, so that means we only need 2 more points. So if we're keeping up with our points, we've got 0, 7, 2, negative 1, 4, 7. I need 2 more. So I'm going to go to the calculator. I'm going to go to the table function, and I'm going to type in my function. 2x squared minus 8x plus 7. Hit enter. Now, I need to look at points that are between 0 and 4. So I'm looking for 1 and I'm looking for 3. 1 is 1 and 3 is 1. So I go plot the point 1, 1, 3, 1. I now have 5 points, so I can draw my parabola. All right, sorry about that. Coach Tipton is now going to stop the video and let y'all try number 2 on your own. After everybody's attempted number 2, he can come back and cut it on for y'all to check your answers. All right, welcome back. Here are your answers. The y-intercept was 0, -5. The axis of symmetry was -4 over 2 times -1, which is -2. So I know I'm going to have -2 something. I got to plug that in. Negative of -2 squared minus 4 times -2 minus 5. F of -2 is -1. So my point is -2, -1. Oh, almost forgot. I didn't draw my axis of symmetry. So -2, -1. Okay. And then if I reflect across, I move 2, so I had to move 2 this way. So that would be 4, -5, or excuse me, -4, -5. If I go to the table function and put that in, I get -3, -2, -1, -2. If you explored your graph a little bit more, you could have seen that you also could have picked 5, 10, or -1, 10. So I could have picked 5, -5, 10, or 1, 10. Those would also work. That's part of my table. Let me make it easier for you to see so you don't get confused. All right, and our parabola looks something like that. Did you notice that this one opened downward, where the other one opened upward? Downward opening. And if you go back to the previous page, this one was upward opening. What causes that? Look at A. Look at A. If A is positive, it opens upward. If we come over here and look at this A is negative. So that means A is negative. All right, so does the function above have a maximum or a minimum? So what is that? What does it have? Look at the graph right there above it. This point right here is what we're talking about. This point right there, is that a maximum or a minimum? It is a maximum. And how can you tell that just from the equation? Because the A term is negative. And that value, A, is equal to -1. All right, so if I look at example 3, determine if the function has a maximum or minimum. So I'll check what color I had. Here's my A term. A is positive, so A is 3/2. That means it is a minimum. And if it wants us to find that value, we're going to do -b over 2a and then f of that. So the x is going to equal negative b over 2 times 3/2. Put that in your calculator, just like you see it. Use the multiple fractions. You get negative 2. And then we're going to plug that in. 3/2 times negative 2 squared plus 6 times negative 2 plus 4. Plug that in our calculator. F negative 2 is equal to negative 2. So our value, our minimum value, is negative 2. All right, if you will turn over to the next page. Lauren is diving into the swimming pool from a point 15 feet above the diving board with an upward initial velocity of 8 feet per second. This is modeled by the equation h sub t equals negative 16t squared plus 8t plus 15. What is Lauren's maximum height? All right, if we sketch the situation is going to look something like that, correct? Here's the diving board, and they're going to dive into the water. So if we're talking about maximum height, we have to find the vertex. So the first thing we're going to do is we're going to do negative b over 2 times a. If I do that, I get 1/4. But that's not the height. That's time. So I have to plug that in. Sorry, it's not F this time. It's H. H of 1/4 equals negative 16 1/4 squared plus 8 times 1/4 plus 15. H of 1/4 is equal to 16. That means her maximum height, Lauren's maximum height is 16 feet. So that means that point right there is 1/4, 16. So what is the appropriate range based on this situation? Well, it's going to go from 0 when she gets into the pool up to 16. It says, what is Lauren's average rate of time for her dive from the time of t equals 0.25 seconds to t equals 1? And what does this represent? So we know 0.25 is the same thing as 1/4. So we have 1/4, not 1, sorry. We have 1/4, 16. And then we have to figure out what 1 is. So we have to plug that in. So we need to do h of 1. That's negative 16 times 1 squared plus 8 times 1 plus 15. And that is equal to 7. So there's our 2 points. So we say 7 minus 16 over 1 minus 0.25 or 1/4, whichever one you want to use. And that gives us negative 12. Now, what does that represent in terms of this context? Lauren's rate of diving is negative 12 feet per second. Remember to sign up for Bronco Block, and I'll see y'all Monday.